Okay, last class we did discuss about scope resolution operator. Scope resolution operator is used to get the variable, static number, static methods. Okay, and then type their enums, all these things, packages. Without creating any object, we can call through in your TB. Okay, so in a TB we can call it. So then after that, what is the next topic we will discuss? I think extend keyword. Okay, what is the use of extend keyword? Extend keyword is used to call um, outside the methods. Okay, methods are declared at outside the class, and then the declaration will be there in your inside the class. Okay, so what is the reason to use the extend keyword means? So extend keyword is used to avoid the multiple lines in your classes. Okay, only declaration will be there in your class, and then declaration is there in your class, and then definition or implementation is available outside the class. Okay, the methods will be implemented outside the class. That methods will be called in your uh, classes. Okay, so that is the reason extend keyword we are using. Now parameterized classes. What is the use of parameterized classes? See, uh, if you are using the parameterized modules or parameterized classes, I want to operate different bits. Suppose I am considering 8-bit bit and 16-bit, 32-bit. Okay. If you are not using the parameterized classes, you need to create each class one after the other. Suppose you want to operate with 8-bit, you need to create the 8-bit class, and then you want to operate for 16-bit, you need to create the 16-bit class. That means the class every time you need to create the new class for that. So while using the parameterized classes, I can override it. Okay, whatever same class is there, but in my TB, whatever the handle you are creating, while creating the handle, at that you are changing your bit of your class. Okay, then the class will be operated. Not only bit, we can also apply that data types. I want to apply the integer data type and then bit data type or string data type or any byte data type. Okay, so that also we can parameterize. Type also we can parameterize and class width also we can parameterize. Okay, so what is the basic concept here? See, imagine some t-shirt factory is there. Okay, so t-shirt factory, so you need to create the cloth is same, but you need to create small size and medium, large, XL, double XL, triple XL, and 4XL like this. Okay. So without these parameterized classes, we need to create each and every time. So each and every shirt at a time. See, so small T-shirt and then small T-shirt class, large, medium, all these things. So we need to write three different designs, but we are using the parameterized. So this parameterized classes, whenever you are utilizing same thing, but the template code is same, but we are changing the parameter only. Okay, so that is the reason we are going with the parameterized classes. Okay, if you want to operate with different widths, different data types, and different objects and different configuration, we want to go for it. We can use parameterized classes. I want to configure my design. Okay, at that time, I will use this parameterized class. I want to configure my data type, bit data type, byte data type, integer data type. At that time, I will use this parameterized classes. Okay, clear? So no need to rewrite all these classes again. So just use the same class. Just change the width of your class. Okay. So while creating the object, how you are creating the object? This is your class. Class packet is the object, right? Sorry, class name. Then how you are creating the object here? Packet pkt, right? Before that, you need to write so packet hash some 16 you want to operate it and then create the packet. Okay, in this way I can override my class. You know already modules I have considered. Okay, parameterized module. How I can override it? So name-based parameterized modules I am considering. I need to override by using name-based. How I am overriding dot width of 16, dot width of 32, or dot depth of 16, or dot depth of 32. So in this way, I am overriding. Here, while creating the object, I need to override the class widths and depths, data types, configuration, and packages, all these things. Objects also we can override. Okay, that's what. Why parameterized classes are required. See, here class packet 8-bit. So single data 8-bit you need to operate it. And again you want to operate for 16-bit, again another class I need to create that. And then 32-bit you need to create the another class. So in this way I need to create each and every data type. So every time you are changing the data width or depth, okay, I need to create the another class. So without creating the new class, I want to utilize the same class, then go for the parameterized classes. Okay. So that is the reason class, packet, hash, and parameter width. We can represent that single width and multiple parameters also we can take that. Depth also you can consider depth equal to 16, comma, and then another thing address width, address depth, data width, data depth. In this way, multiple parameters also we can consider. All these things are override. Okay. So and also type also we can consider that. Hmm. So just we can use the comma to segregate type and width. So type parameter. So how we are creating the type parameter here? So just see this class packet data t equal to int. That means data type. Data underscore t means data type. What is the data type I am utilizing here? Integer data type. And someone came that you need to use the logic. Then data type t equal to logic we can place it. And then everywhere it is converting to logic. After that you can use the another data type like byte. Okay, so just I am changing this variable. Okay, then I will create that. So type data t and then integer. So this data t is the data type is the parameter. So if you are using this data type t data t underscore instead of integer, we can use that bit, or you can use that byte, or you can use that string or enum or type of anything. Anything I can implement. Okay, by using parameterized data type. Okay. So how I can use the both like parameter width. Okay, width is the 8 I am utilizing and type data t. Okay, so type integer data type, or you can use that bit, or you can use that byte. Anything you want to utilize it, you can utilize it. After that, see, he is utilizing bit data type. So bit and data type data ID. So type is the ID. So based on that, he is mentioning. So then the default parameters are, what are the default parameters we are using? Bit is the default parameter we are using. And then normally whatever the parameters we are using, width, we are mentioning that. Okay, whatever the width that is default to 8-bit, we are utilizing that. Okay, so bit is an 8-bit because here mentioned the width is 8. Okay, so then we 8 minus 1 down to 0. What is the value we are getting? 7 down to 0. Okay, 7 down to 0 means 8 bit. After that, you want to override it. Okay, how we can override it? What is the class name? Packet. Okay, use the packet is the class name, and handle for that. Before that, how much width you want to override it, you can mention. Okay, and create another object and use that another bit. Okay, either 16 bit or 32 bit or 64 bit, 128 bit, how much you want, you can write there. Okay, here class packet hash parameter width, and then so here the width value will be changed 16, 32, 64. In this way we can change, and then bit I have applied here. So because data type I have considered the bit, and then data is the my member, and then method is I'm utilizing the method to display the bit as well as whatever the data I'm considering, that data also I will add here. Okay. So remaining all the rest of the things are same. How you are creating the module, class name, and then handle. After that, another object you are creating, that multiple objects I am creating. After that, after creating the handles, I need to create the object for that. Here, null object we are representing. After create new method we are using, then object is created. Then assign the values to that. Here, 8 bit you consider, 8 bit the value we can apply. Okay, 16 bit you are considering. So the previous bits also it is supported. Okay, so if you are applying that 16 bit width, then I am also giving the backward compatibility for 8 bit or 4 bit and 2 bit. Okay, so you can also write that P2 is P16 is the handle for that, right? P16 dot data equal to 8 bit I can give that, or 4 bit I can give that, but don't give the 32 bit. If you are assigning the 32 bit, the rest of the values will be truncated. Okay, whatever the lower 16 bits are there, those lower 16 bits only it is considering, and the rest of the things are not considering. Suppose I am writing here, so P16 dot data equal to 32 tick hexadecimal AB, AB, and then DEAD. Okay, in this way you consider only these values are appeared at the output side, these values are not appeared at the output side. Okay, those values will be, those variables will be truncated. Okay, if you assign the higher value compared to the assigned value. Okay, clear? Similarly, I am utilizing the type also. Okay, so what is the truncation? I told you, no. So truncation means, see here, you are applying the data. Truncation means you are using the data width is 4 bit, and then you created the parameter the object also for 4 bit, and created the object, you assigned 8 bits. Okay, so B is only printing, A is truncated. That's what the truncation means. Okay, here type parameter. Type parameter means data type. Okay, what is the data type I'm utilizing? You are utilizing the integer data type or bit data type. Okay, whatever the data type you are utilizing, based on that, it is appeared on that output side. Okay, so just you are taking that parameter is t data. T is representing the type. Okay, what is the type? Integer data type. Okay, int data. Instead of int, I am using the t. Wherever the t is there, all the places we are replacing the integer data type. Then you came next one is other person came that okay integer is taking too much time. You can replace that bit. Okay, just I am replacing the t value with bit. Whatever the numbers are there, all the members are changed to bit type data type. Here, that is the type parameter. So remaining rest of the things are same. Function void dollar display, then value will be printed here, and again module I am creating. See, my class name is container. Container hash int c1. See, integer type I am considering. Then later I am considering that string data type. Okay, hash string c2. Okay, c2 is the another object. Same class, I will create multiple objects, right? One object integer data type I am considering, another object string data type, another object byte data type, another object logic data type, another object enum. So in this way, I will implement all the data type for the same data. Okay, here. That is the reason we are going for the type parameter. So type parameter, whatever the data type is there, that data type will be changed. Okay, c1 dot data equal to 100, and then because it is a integer data type, and c2 is a string, then c2 dot data equal to VLSA verify something we are using there. Okay, so and then c1 dot display, c2 dot display, we are utilizing. Okay. Widths plus parameters. Combinedly you are considering. Previously, width I am considering, type I am considering. Okay, type parameter I have applied, and then width parameter, that means data type, whatever the length, whatever the width you are considering, that we are applied. Now, what is the another parameter? Hmm. So integer data type we are using. Okay, type. See how we are applying here. Just we are separated with comma, right? See here width is related to 8, and then type is related to integer data type. So how we are applying previously packet I am considering hash some 16 I am considering. This 16 is related to width. Okay, so after that again packet hash integer I am considering, and then this integer will be replaced with string or any bit, any type of data type. So in this way I am considering. Now both are applied at the same class. Okay, so now same thing, packet hash some 16 comma bit you can apply, or 17 32 comma string you can apply. Okay, same class, different bits, different data types. Okay, but how we are implementing through handle. Okay, whatever your class name, through handle only you are implementing all these things. Okay, then transaction tr and tr2 is the methods create object creation. After that, another data I am applying here. So data and id, and then transaction 2 dot data, and then id we can apply the display we can use. Okay. Same thing I'm applied for the parameterized FIFO. FIFO you know, right? So write operation, read operation, and then full condition, empty condition, write enable, read enable, write data, read data, all these input output variables I have considered. Same thing here also, we are applying the queue. Here I am using the queue here. In that queue, see, queue is also operate like a FIFO because we are applying the pop and push operations, right? So pushing the data means front side we are pushing the data, and popping the data means you also popping the data from front side and back side. So it's like a FIFO only. Okay. So in real time industry they are using queue or FIFO, anything, both are same. Okay, instead of FIFO we can use the queue. The queue data will be stored because queue size will be shrink and then expand. Okay, based on the methods. Those are inbuilt methods are there. Push method is there. That means you are pushing the data. empty queue is considered, and you are continuously pushing the data up to the depth location. Then up to that we are continuously writing that. Then the queue will be filled. That is P4 will be full. After that, popping the data. Hmm. Continuously you are popping the data. Up to that depth will be count equal to 0. Once the depth count equal to 0 means queue is empty. That means P4 is empty. Okay. Same operation. Nothing will be difference. Okay. Same thing. I'm using the queue here. So whatever the queue I'm utilizing, this is the queue. Dollar you are utilizing means what? Infinite size, right? Okay. So, but you are using the dollar at initial condition and then giving the maximum condition, then it is up to 256. Then this dollar will be creating zero condition, and then you are creating the some 150, 125 or 128, right? 127 to infinity means up to 127 to infinity means then the before values you are not considering. So where the dollar is present, initially it is present, it is taking as 0. Final condition you are placing the dollar infinity. Okay, understood, right? So before class packets, parameterized packets. So what is that parameterized packets? So class packet you are using, that means group of data, address and data is also using them. Okay, so multiple members we can apply that. That is the packet class we are using there. And then parameterized class with another class type. That means the type will be changed. See, error transaction class, error info I have considered. Another class I have considered here with type. Okay, some error info I am considering because see, parameterized class with another class type. Whatever the class here I am using, error info. In that, bit error is there. That class I am utilizing here as a data type. Okay, type error is equals to error info. Error info is my class name. Then uh, nested class you know, right? In shallow copy I am using the nested classes. Class A inside the class B, class A handle I am utilized. Here same thing. The parameterized with the classes. Okay. So same class I can utilize in my base class. Upside class is the subclass and then below class is the base class. Same class we are applying here. Okay, because this error t is the error you are using. Same thing. Another handle I am utilizing that. Again, error equal to new object created. So then how we are creating how we are calling the data, transaction dot transaction class is the this class. Okay, I want to call this error. Okay, how I can call that? So why you are taking this error t? Error t represents that error info. Okay, directly I am not assigning the class name by I am utilizing the type parameter. Okay, type parameter I am utilizing that based on the type parameter I am assigning my class name. Okay, clear? So then you can call the error by using transaction handle and error. So after that error class. Okay, so based on that only we can call that. So error is that handle of this one, and this is the handle for what? Error info. Based on that only we can call the error data type. Okay, so that is the value we got that. Same thing. So shallow copy type, but same object I'm utilizing. Okay, remember. Uh, Parameterized scoreboard class also we are using same class but name is different. Okay, scoreboard I'm utilizing inside the type t equal to integer. T is that integer data type, and then you are taking here expected value type is int t, that means integer data type, and here also t, that is integer data type. Okay, I can use the method to call here I'm placing the data in my queue. So how I'm placing that expected dot push, uh, expected dot push back method. Okay, and then actual dot push back method. Same data I'm pushing that. So I'm considering that. How we can compare that expected value with. So in comparison, just I'm utilizing the strings comparison. P1 some string 1 is compared with the string 2. How we are comparing? Same way expected dot compare. I'm utilizing the actual. Okay, so that means whatever the handle P2 dot compare P1. Okay, so P1 is comparing with the P2. Same thing. Here also I'm comparing the expected values and actual values. Expected values means we know 2 plus 3 5. I know that. Then actual values also I need to get the 5 only. Then only my scoreboard is passing. Otherwise, I don't know what is happening. So failure will be happening. We need to debug that. Okay. So understood, right? So in UVM style, parameterized classes we can also use that. So why these parameterized classes we are using means in UVM sequence item is the transaction class. Okay, that sequence item we can call it in your sequence class and then driver class also by using parameterized classes. Okay, so this parameterized we are utilizing. Previously I am utilizing that. So class error info is my class. That class will be utilized in my transaction class. Hash some error t equal to error info I am utilizing. Similarly, whatever I am writing here, just class driver is my class name. Class driver is my class name. Inside that, I'm utilizing the parameterized class. So, what is the parameterized class? Some sequence item. In this way, I can write. Okay. So that is the parameterized classes. Class with another class we are using. That is the UVM style. See, class driver hash type request equal to transaction class. Transaction class is somewhere else. That transaction class here SV we are calling it transaction. In UVM sequence item. Okay. Same thing, driver class you are creating here, driver packet, driver 1, and then AXI packet, driver 2, and then AXI USB packet, driver 3. In this way, you are creating the different drivers, like parameterized classes you are utilizing, right? So instead of transaction, we can write multiple transactions. That is the reason we are creating each and every driver individual objects. So remember this concept because in UVM, create will come. Hmm. Why you are not using new instead of why you are using create instead of new means here new method the driver one is there. I am creating the object. Driver two is there. I am creating the object. Driver three is there. I am creating the object. Okay. Suddenly you got the error in your driver two. I want to replace the driver two only. Okay. So overriding is not possible in this new method. The create method gives that overriding. You want to replace the driver to, you can replace it. You can override it. New driver. Pointing the base driver, but new driver will be operating instead of old driver. Okay. So I told you overriding concept. So I will explain in the overriding concept. Okay. Just inheritance parameterized, that means extended keyword we are using, right? So a class parent we are using, and then this type of style we are utilizing in the UVM. Okay, class style hash parameter and then extends parent hash width. Okay, so that width we can override. See, parent width is the normal width and then child width is the parameter I'm considering. That width means here your parent width is 8 or 16, 32, anything. And then child width we can override it. Okay, like the 32, 64, 128 in this way. Okay, this is the inherited class parameterized classes. Okay. See, parent automatically gets 32. See here, child is 32 is there, right? So obviously, parent is also getting 32. That is the inheritance. So child class properties and parent class properties we are using, right? This width is overridden with 32. So then this width is also having 32 here. Okay, child is assigning the some width. Same width will be assigned to parent also. Okay, so then parent also becomes the 32 bit because you are assigning the bit to your parent also. If you remove that parent bit, then parent will be 8 and then child will be 32. Okay, there is no assigning the parent class child class bit to parent class. If you want to assign that, you can use the parameterized class for the parent also. Okay. So same thing, memory model, we are applying that address width, data width. Address width is the another data type, and then data width is the two-dimensional array you are considering. Two-dimensional array, A is that left hand side, width we are considering, right hand side, depth we are considering. Okay. So this is all about the parameterized class. So simple example, class you are considering, inside that parameter width you are considering, and then type. You want to override it, you can override in your PB. Rest of the things are same. See, but object creation, data assignment, calling the method, all the things are same. Whatever the normal class you are considering, class, data, and then whatever the properties and methods you are considering any class. And then module, DB. So inside that you are assigning the handles for the classes. Okay, after that creating the object and then assigning the handles, sorry, values. After that calling the method. This is the normal class method we are writing, right? Instead that parameterized classes you are taking the width and type in your class. Then while assigning the handles to your class, you are assigning the width and the type also beside the class handle. Okay. After that you are creating the object. Yeah. So this is the summary. You can read this, and then we'll execute one of the two programs. See, last one we are seeing, right? Advanced example. What is the example here? Class, transaction, and then parameter is the width, and then type is the integer data type. Then rand bit. So randomization, you know, right? Rand bit with the data we are width minus 1 down to data. That means width is 32, right? Then here we can apply the 32 here. And then IDT, that means ID type. Okay, type ID is that integer data type. Okay, then we are calling the function here. I'm representing the function void print dollar display. I can print my weight, type, and then data. So width equal to percentage 0t, data equal to percentage h, okay, and then ID equal to percentile 0p, okay. So width equal to width comma first variable is width and then second variable is data and third variable is ID and class normal thing, okay, and then module TB. What is my class name? Transaction. For that I am creating the handle. Before that you need to assign the values for your weight and as well as type. Okay, so one transaction I want to shrink my width, previously is 32, then it will support that 8 also, 8 comma integer data type. Okay, and then transaction I want to override with 64 because I am using the string data type second object, and create the object for the two handles and then assign the values for that. Okay, transaction 1 dot data equal to AA, transaction 1 dot ID equal to 1. So ID is the single bit you are considering here. Okay, and then Data we can assign here 64 bit. We can assign the 64 bit, and then ID is that packet 1. So print the values. Save and execute here. See, you got that 8-bit data, and then if you want to override another one, so take that another class. What is the value you can consider here? Transaction 3. I am adding here 128. 128 string is the other name, and then instead of the transaction 2 you need to create the another handle transaction 3, and then create the memory for that. So tr3 equal to what is the handle new method we are using, right? Okay, so I'm using the new method for third handle. Similarly, transaction 3 handles I'm assigning the data here. Okay, so transaction 3 data equal to 128, right? So 128 hexadecimal. After that, so we can also see instead of that you can use the underscore. Based on that, we can segregate how many bits we are applying at a time. Okay. So one date, and then beef, and then another thing we can apply uh, cab. Okay, uh, cab, and then print method we can use that another packet here. I'm using that transaction 3 dot print method. Okay, just I am applying the another transaction. So this print is common, right? Method is common for everything. Okay, save and execute it. In this way we can create multiple objects and multiple uh, bits and types also. Okay, see, what is the value we got? 128. What happened here?
Sir, try to ID in in you even try to dot ID, try 3 dot ID.
Okay, okay. So data 3, right? So 3, and then here also 3. Transaction 3 dot data and transaction 3 dot ID and transaction 3 dot print. I'm assigning that. Okay. Now you got the output, right? So in this way, you can assign the class parameters. Okay. Just take 2 minutes break, and then so next topic is encapsulation here. Uh, what is meant by encapsulation? Just tell me what is meant by encapsulation. You are going to ATM, right? Uh, so you are going to ATM and then withdrawing some money, right? And you are not showing any data to your password. You are not showing. You are not revealing the data related to your password and then account details, all these things. So some masking is there. That means encapsulation is providing the uh, protection. That means hiding some data. You are opening your bank account through net banking. You are entering your password. Is that visible to another network? No, it is encrypting. Suppose you are entering the password like the password went at the rate some 1 2 3 4 5 6. In this way, I'm utilizing my password. Okay, so this is my strong password I'm utilizing. Okay, so whenever whenever I'm entering my password while going to the internet, it's not visible that same password. Okay, it's converted to hash, some 246 or at the rate. In this way, the values will be, the password will be converted, encryption. That means hiding the data. Okay, encapsulation. We are wrapping the data and then members also in the one place. That is the purpose we are using the encapsulation. So and also you are driving a car. What you are seeing, steering you can control the wheels. Okay, and then some other switches you can see. Okay, AC switch or the, um, uh, petrol open. All these things we are seeing the outside switches only. Have you changed the data related to your engine? So engine parts you can replace it, or engine parts are you touching that? No, right? So some official data I want to, so no one can touch it, right? So in your colleges also, while going to the examination cell, so entry restricted something board we are seeing, right? So I can also see it while going to entering into that while I'm trying to entering into that. So some of the faculties are stopping me. Okay, same way here also. Data encapsulation is providing the protection to some data. See, that's what he's saying that before understanding the encapsulation, we need to know that local, protected, and public. Okay, local means same within the class only we can use that. That is the local variables. Okay, and then protected. You saw that yesterday protected we are using. Then protected we can access in your class and child class also. Okay, public means anyone. Default is a public. Okay, so that means you can use that class and also used in your child class and also used in your module. Okay, you can use in your module. That is the encapsulation. Inside that encapsulation, we need to know that local, protected, and public. So public we can operate anywhere. Okay. So that's what he is saying that imagine a car. Okay, so that car is what is the variable we are using? Imagine a car. Okay, you can drive the car using the steering wheels, right? Check the speed, dashboard, all these things. But you cannot modify the engine internals. Okay, so while driving, right? You can't change your. At least we know something to if any time, any day the car is stopped and then somewhere else means we need to check is that plug is correct or any water is coolant is heated. We need to pour some water. All these things we are checking. Not internal parts, right? So are you changing the engine oil? No. So we don't know where is the piston is there, which one we need to open, all these things. Okay, that is the reason some of the data is hiding. That hiding is called as okay. So this is the data hiding. This idea is called as data hiding because no one can change the data, right? If you reveal your account details, all these things, then anyone can manipulate your data, right? So steal the money or change the account numbers, all these things. Okay. So that is the encapsulation. Encapsulation means combining the data and methods in a single unit. So that is the data encapsulation. Okay. So combining the data and methods into single unit. So whatever the data, this is the data, then method. So in this, that is called as a data encapsulation. That means we are using everywhere class, class name, members, and then methods, right? Same thing. Here, data then displays the behavior. That means displays the behavior to call the data. That means we are wrapping around that. That is called as encapsulation. That means I am representing my members. I am calling through members. I am calling the members through my method. The method displaying the whatever the members you are utilizing in your class, right? Clear? So what is data hiding? Data hiding means preventing the direct access. Okay. directly no one can access the data. So that is the secret data we are using. So for that purpose, we are providing the protection for that. Okay. So then this is the local integer data type we can use in this class only. Okay. So without data hiding, see, no, someone can change that negative balance, and then size is negative. Okay. So anyone can change the data. Suppose I'm giving the access to my drive, so I'm protected my data. What is that? You can't change the data. You can see the data. Okay. You don't have the permission to change the data, right? So that is the, but you have chance to add the data. Okay. So then, you own a car and you want to modify the car. Interior you can modify it, but internals you don't want to modify. You don't have the access to modify. Okay. Only engineer, mechanical engineer only is doing the modification, right? Same thing here also. See, what are the qualifiers here? Local. Local means only accessible by the child class only. No, even child also not having access, and then outside the module, that means TB also not having the access. Okay. And then protected. Protected is having both the child and the class, and child class we can access it, and module we don't have any access. How we can access this protected variable? We can assign this protected variable in your method. We can call that method in your TB. Okay, yesterday we saw, right? I am not having the permission to call directly whatever the protected members are there. Okay, so protected data types are there. That protected data types I cannot call directly in my TB. I can call, but using the methods. That method will display the protected. Okay. Default, that means public. I am also access. You can also access that, and you will also access that. Okay. So public member is default. So normal class. Nothing will be the difference here. Class, member, end class, transaction, and then you are assigning the data display. That's it. Normal class name. After that, local variables. So you are using the keyword is called local here. Okay. Hmm. This is the local keyword. I'm using the constructor to print the value. I can assign the value through constructor and then call through the constructor. I have created that, and then if you assign the value, then you will get an error. So access to the local members is not permitted to outside the class. Okay. Inside the class only we can access that. Then only we are getting that. And access local variables through methods. I told you now methods, through methods we can access that because I have displayed that value in my method. I'm calling the method, not calling the property. Okay. So int id is my property, okay, local property here. So then I'm added here display method. In the display id I am displaying, that means 100 you are assigning that, and the 100 will be assigned here. I can call this display method in my TB. Okay, this is my TB. Then I'm getting the output is 100. Same thing, local methods. You can also use the local methods also. So same local methods we can use in your class only, and don't call this local method in your PV. Okay. So we don't have the access to call methods in your module. Okay. Just display only. So we can already display that. So whatever that we have using this run we are calling. Method run, I'm using that function void run. That run we can return the helper. Helper is related to your local method. That local method is written in your run function, run method. That run method we can call it. Okay. So don't call directly. That is the only theme here. Okay. Local constructor, that means whatever that constructor we are using, that means function we are using, right? And constructor also we are using the local. Okay. So just local function void initialize that data and end function, and you are initializing that data in your constructor method. So user cannot call transaction dot initialize, because initialize is the your method name, local method name. That local method name we can't call directly in your module. Okay, we can call through constructor. I can call the constructor. Local versus public. Public means you can access anywhere. Okay, local means within the class only. Okay, local inheritance. Same thing, child class we can access that, but this ID we cannot have the access to your child class also. In child class, we want to override the method, you can use the method, and then another method you want to write it. So then you can get the data type. Otherwise, we can't call the directly whatever the properties in your local class that can be not called in your derived class. Protected members. Protected means we can access your normal class, parent class as well as child class. Okay, so both can access that, but module can't have the access. Okay, outside the class we don't have the access. Okay, understood, right? So and then here I am using get method and set method. Get method we are getting the data, and then set method we are inserting the data. Okay, so that is the reason I'm using the set and get method in my local transaction. Here I'm utilizing what is the ID here, local int ID, and method is function void set. Then ID value I'm setting here, whatever the I value is there, that is related to your ID end function, and then get method, so I'm returning that ID value, returning the ID, because I value is assigned to ID, right? I can return the ID value. This can be accessed in your module. Okay. So set method 55 I can set that, and get method we can get the 55 value. Okay. So in this way I can call the local variables. Same thing, but I am using the two methods, set and get methods. Okay. So same thing, counter, encapsulation counter, local thing. You can use the increment counter in your method. Then verification transaction. Like transaction, I'm using that. So local checksum. I'm checking the error. Yes, checksum. And then function void randomize here and assigning the address to that. So address, that is normal variable, public variable, right? This is public variable, and this is local variable. Okay, public we can access in your module as well as class also, and child class also, anywhere we can access it, but local within the class only. That is the reason another function I have created here. I can call this method in my TV, then I will get the output of my checksum also. Okay, same thing. What is the illegal here? Calculate sum is the illegal, because calculate checksum is the name. So through checksum we are assigning the data here. Because this checksum is the local variable. Okay, we can't access through module. So that is packet calculate checksum is illegal. Okay, packet checksum is also illegal. So that is the reason we are not utilizing, and I can call this method only. What is the method here? This display method. This display method will get the output of my checksum. Just see the code execution. See, industry example I am taking that type def class driver. So why you are using type def to the class driver? So user can create their classes, right? So type def classes. I will explain this type def classes last slide in this PPT. Okay. So then class transaction and then grand bit address I am taking. So this driver handle I am creating here. Driver handle function void display. I am displaying my address and data here. So address I am displaying here, and then class driver. So in this class driver, what is the handle I am using? Transaction class. Okay. So transaction class I am utilizing here, and then I am adding this one. I think it's this one. This example is related to type def class. Okay. Don't go for this one. Okay. Type def classes only. Without explanation of type def, we can't understand, right? So shallow copy, deep copies methods we are implementing here type def classes because one class we are calling with the another class. Okay. Uh, This is public variables. Public variables means normal classes. No need to explanation. No need of explanation, right? So this is anyways you are writing normal classes, class members, methods in class, and then transaction, module DB, class handle. After that, assigning the values and displaying. Simple method. Okay. So now whatever I am using local variables. See, local variable class transaction local int id, and then constructor I am using that. So I can call through this method directly in my DB. If you are assigning that the transaction.id equal to error we are getting, right? So just see what type of error you are getting. Transaction.id we can't assign directly in your module because what is the error? Local member ID of class transaction is not visible to your scope DB. Okay, in DB we can't access directly. Okay, yeah. Um, can we use scope resolution operator for that? Transaction class scope resolution and then ID we can assign the value. Okay, scope resolution we can get that static members and then local members we can't get maybe. So, so in you if you want to get that local members, we can call through method only. We can call that method. Okay. Clear? So that means you need to comment this one and then save and execute this one. We'll get the output called 10. I'm getting the output is 10. See, ID is 10. Okay. Same way, what is this? Local access through methods. So I told you now access through methods. So through methods I can access this one. Just same class, above class only. Just I am using the method to display the variable here. I can display my variable. This method I can call in my TB transaction T class module TB transaction class initial begin new memory and then dollar display. Sorry, transaction dot display we can use that, and then we can get the value. See, ID value is 100. Understood, right? So anything new here? Local transaction. Child class we can explain here. So this is normal method. Helper we are using, that helper we are displaying here, and then we can't call that the helper directly. and then class transaction, same thing here also, and then I am using this parent class. Okay, class parent, local int id, and constructed method I am assigning the value, and I can set that get the id value. Okay, so get the id, return type is id, and then child class also I'm using class child extends parent, and then so we can't assign the value directly, so this is the illegal access. So dollar display id equal to id. Okay, so we can use that, just this is the illegal method, and we can use this display method id equal to percentage 0d get id. Okay, so we can use that one. And module db, so how we are is displaying that c dot display, so this display method we are calling that through child handle I'm calling that. So this is normal method, right? So whatever the method we are using, so same thing will be displayed at the output